Okay, so now that we've done absolute value within an inequality, we're now going to deal with two variables. So when you draw a line on a coordinate plane, that line is called the boundary. Okay, the line that you draw is called a boundary. And each plane that it cuts it into, so the plane above and the plane below, those are called half planes, or they're cutting them into regions. A closed half plane means when you draw the line, you are going to have a solid line. An open half plane, excuse me, means that you're going to have a dotted. Because solid has the or equal to's on it, where the dotted or the open half plane is going to have greater than and less than. So first things first, we're going to graph the boundary. So basically what we're doing is we're just graphing like we've done before. So we're going to look at this. So we're going to, now, could you do this with y-intercept and x-intercept? Yes, but 3 doesn't go into 8. So I'm actually going to solve this and get it into the slope-intercept form. Divide everything by a -2. Remember, when you divide by a negative, you have to change the inequality. So I'm going to get 3 over 2x minus 4. So as I'm looking at this right now, this right here, that's a greater than. It doesn't say or equal to. So that means that this has to be a dotted line. And it's a positive slope, so we're going to be going up. So first off, I have a y-intercept of -4. So I'm going to come down to -4. 1, 2, 3, 4. And I have an open dot because that's greater than. It is not or equal to. I go up 3, 1, 2, 3, and over 2. 1, 2, 3, and over 2. And I'm going to make a dotted line. Like so. Now, we graphed our boundary line. And now we're going to use a test point to determine which half should be shaded. So one of these two sides is going to be shaded. Now, I'm going to give you a hint. If this point right here at 0, 0 is not on the line, that's what I would use. I'm going to use 0, 0 as my test point. So let's look at this. So if I plugged in 3 times 0 minus 2 times 0 is less than 8. That's going to get me 0 is less than 8. Okay, is that a true statement? That means it is a solution. Now, could I have picked a different point? Sure, I could have picked this point right here. So if I had picked -1, -1, so that would have been 3 times -1 minus 2 times -1 less than 8. So -3 plus 2, is that less than 8? So -1 is less than 8. So it's an answer. It's a, it is a solution. So it says up here, shade the half plane that contains the solution. So that means I'm going to shade this side. Okay, so let's try it again. First things first, we're going to graph. Well, this right here says that it's going to be a dotted line. So I'm going to subtract. I get y is less than -2x minus 4. Okay, that's a negative slope, so my line is going to be, that's funny, they have the same y-intercept. Oh, is it the same? No, it's not. So I go down to -4, 1, 2, 3, 4. I open dot it. I go up 2, 1, 2, and make sure I go the negative direction. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And then I would draw a dotted line. Now we have to decide. Now again, 0, 0 is the easiest one to plug in. You don't have to do that, but I like to do that one. 2 times 0 plus 0, is that less than negative 4? So 0 less than negative 4. Is that true? No, it's not. It doesn't work. So the point 0, 0 does not work, so the other side will work. Now, if you want to see to make sure that that works, we can take the point, I don't know, negative 5, 0. Because 1, 2, 3, 4, this point right here, we're going to see if it works. So 2 times negative 5 plus 0, is that less than negative 4? So negative 10 is less than negative 4. That is a true statement. That is a solution, so that side would get shaded. So let's come over here. Let's do the exact same thing we've been doing. So I subtract. Interesting how all of these are dotted lines. Oops. Greater than negative x plus 4. Divide by negative 2. Because I'm dividing both sides of the equal sign, or the inequality, I have to change the direction to 1/2 x minus 2. So it's a positive, but it's still dotted. So here I come to negative 2. I plot my point. I go up 1 over 2. Up 1 over 2. Or I could have gone down 1, but to the left 2. Down 1 to the left 2. And then I draw a dotted line. Like so. Again, I like to pick 0, 0. You do not have to pick 0, 0. 0 minus 2 times 0 is greater than 4. Is 0 greater than 4? No, it is not. So that means that this side right here is the solution. Okay, so right here it says, when selecting a test point to use, make sure that the point does not lie on the boundary line. While using the point 0, 0 will make calculations easier, you cannot use that point if the boundary line passes through that. Okay? So let's look at this one. So I'm going to subtract 3x from both sides. I'm going to get 4y is less than or equal to negative 3x. Divide by 4. Divide by 4. I get y is less than or equal negative 3/4 x. Okay, so if I look at this as a negative slope, it has a solid line because it has the or equal to. So the y-intercept is 0, 0. So look at that. We can't use 0, 0 as our test point because it goes through 0, 0. So my slope is negative 3/4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So that means you want another point that's easy to plug in. Personally, I would use 1, 1. So 3 times 1 plus 4 times 1, is that less than or equal to 0? 3 plus 4, that's going to be 7 is less than or equal to 0. That does not work. So that means this point right here is not a solution. So it's the other side that gets shaded. Okay. Okay, refreshments. Dominique can spend up to $20 to provide the dance squad with drinks after their practice. A bottle of water costs 80 cents. A sport drink costs $1.25. How many bottles of water and sports drinks can Dominique buy for the dance squad? So I'm going to say let X be water. Let Y be sports drink. Now, it was nice that they gave us that information there, but I actually didn't even realize they gave it. And I was defining my variables. So, here we go. It says 80 cents for water plus $1.25 for the sports drink. And it says up to $20. So less than or equal to 20. So if I was to plug 0 in, now, we could just do it this way. If I was to plug 0 in for X, that would be 1.25Y is less than or equal to 20. And I need a calculator for that because I'm good with math, but come on. 20 divided by 1.25. 16. Definitely should have known that, but I didn't. So this is going to be 16. Okay, so if I was to plug in 10, so that's going to be times 10 plus 1.25. Does anybody see now why we solve for y? Because otherwise, we're going to be solving over and over. So I subtract 8. Here. There we go. So that's going to be 12. Divide that by 1.25. Let's see. 12 divided by 1 point. Oops, that's not 1 point. Y is less than, it's 9.6. Okay. And we have 0.8 and multiply that by 15 plus 1.25. So 0.8 times 15 gets me 12 plus 1.25. I know I should have this already done. 0.25 is 8. 8 divided by 1.25 will get me 6.4. And last but certainly not least is 25. Oops, I forgot the y again. So 0.8 times 25. Again, I should know that. $1.25. It's me 0. So y is 0. So 0, 16. 25, 0. And there you have it. Okay. So if I'm looking at this, if she buys 0 water, she can get 16 sports drinks. If she buys 10 water, she can only get 9 sports drinks because that's 9.6. 15 water, she can only get 6. But if she buys 25 water, she can only get, or she can't get any sports drinks. Okay, so here we go. I add, oh no, this doesn't have a y. Okay, so it's going to change the inequality to x is less than or equal to -1. Okay, so if I'm graphing that, that's going to be a vertical line. So I come down here and I go to x is -1, which is right here. I make a vertical line. Then I have to plug in. Again, I'm going to do a test point of 0, 0. If I was to do a test point of 0, 0, -4 times 0 plus 7, is that greater than or equal to 11? So 7 greater than or equal to 11. That is untrue. So that means this side is shaded. Come over here. Oh, I don't even have anything to do on this one. Oh, I know what this is. So we're going to graph this. I'm going to bring it down here. Okay. Sorry, I had to remember what was going on. This is going to be a dotted line, so that's going to be there. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And we're deciding if these are solutions. So if I'm going to take this one right here, -5, -3. So we're going to decide, oh, I forgot to shade. Hold on. Forgot to shade. If I did the test point of 0, 0, 0 is greater than 3 times 0 minus 4. So 0 is greater than negative. Is that true? That is true. So this side. Okay? So the point -5, -3. This point right here. Is it a solution? It is. Now, could I have plugged that in? Sure, I could have plugged that in. -5 greater than 3 times -3 minus 4. So is -5 greater than -9 minus 4? So is this a true statement? That is a true statement. So that is in the solution. So -5, -3. Okay, if I was to pick 0, -4. 0, -4, this point right here, is it a solution? So if I plugged that in, so -4, and then we have 3 times 0 minus 4. Is -4 greater than -4? No, absolutely not. So that's not a solution. Okay, then, I don't know, blue. If I used 1, -7. So -7 greater than 3 times -1, not -1, how about +1, minus 4. So -7 is greater than 3 minus, so is -7 greater than -1? No, it's not. So 1, -7. Then if I did 2, 2. So 2 greater than 3 times 2 minus 4. Is 2 greater than 6 minus 4? 2 greater than 2? No. Okay. So -3, -4, or sorry, +4. So 3 times -3 minus 4. So 4 is greater than -9 minus 4. So is 4 greater than -13? It is. So this would go here, -3, 4. So 0, 0. 0 greater than, oops, I wanted a different color. 0 greater than 3 times 0 minus 4. So 0 is greater than negative 4. That is true. Look at this one. So 1 is greater than 3 times 1 minus 4. 1 is greater than 3 minus 4. 1 is greater than negative 1. That is true. And then, last but not least, 2 is greater than 3 times 4 minus 4. So 2 is greater than 12 minus 4. 2 is greater than negative 8. Oh, not negative 8, positive 8. Nope. Okay, so, but the problem, or not the problem, but what you should be doing is, if you have graphed this correctly, all you have to do is look at the points. If I was to look for the point, it was a green one, negative 3, 4, so 1, 2, 3, and I go up 4, this point right here, is that in the shaded area? It is. If I was to look at 0, 0, this point right here, it's in the shaded area. If I looked at 1, negative 7, 1, 2, 3, 4, 5, 6, 7. Down there, that's not in there. So that's not a solution. So could you plug it in? Yes. Could you just look at your graph? Yes.